Hello, you're welcome to my channel today. Today we'll be treating a very interesting topic, standard form. What is a standard form? A standard form is an expression of numbers in scientific form to reduce the space and stress of writing very large numbers and very small numbers. A number is said to be written in standard form when it is written in this format. A times 10 raised to power n, where A is between 1 to 10 and n is an integer. And we all know what an integer is. An integer is a whole number. N can be a positive whole number or a negative whole number. For instance, 8.0134 times 10 raised to power 4 or let me say 2.145 times 10 raised to power minus 3. These both numbers are all in standard form. You can see here the power of 10 here is a positive whole number and the power of 10 here is a negative whole number. The position of the decimal point will depend whether the power of 10 will be a negative sign or a positive sign. Now we're going to solve some examples under standard form. We're going to express all these numbers in standard form. The first one is a decimal number. The second one is a whole number. The third is a decimal number. The fourth is a whole number. Expressing them in decimal in standard form solutions. Number 1. Moving over to number 1, you can see that we are given 0.000048. It's a decimal number. For us to convert this decimal number to standard form, what are we going to do? Remember what I told you, a number is said to be standard form when it is in this format, 8 times 10 raised to power n. Now, this is where our decimal point is placed. We are going to count this decimal point. We're going to carry it and place it immediately after the first non-zero digit. Immediately after the first non-zero digit. And our first non-zero digit here is 4. Now, let's count. This is where our decimal point is. We count 1, 2, 3, 4, 5. Now we have 4.8 times 10 raised to power minus 5. This 5 here is the number of digits we counted before placing our decimal point. And then the negative sign here is because we counted from the left side to the right. If you are counting from the right to the left, it's going to be a positive power 10. But if you are counting from the left to the right, your power 10 is going to be a negative integer. Now let's solve the second one. The second one is a whole number. Number 2, we have 1402000 is equals to. Now this is a whole number. There's no decimal point. Once there is no decimal point, we're going to assume that our decimal point is placed at the back of the last number. Here, now we're going to count and place our decimal point before the first digit. Remember, before the first digit. Now we count 1, 2, 3, 4, 5, 6. 1 is the first digit here. Therefore, we're going to place our decimal point before 1. Now we're going to have our 1.402 times 10 raised to power 6. We counted 6 numbers, 6 digits, before getting the position of our decimal point. And we counted from the right side to the left. That's why our power 6 has no negative sign. It has no negative sign because we counted from here to here. But if you are counting from this side to this side, your power 10 has to have what? A negative sign. This is our final answer for number 2. This one is for number 1. Now, number 3 question, we have number 3, 0.09. Converting this to standard form. Remember what I told you? You have to place your decimal point immediately after the first non-zero digit. And our first non-zero digit here is 9. We count. These are decimal points. 1, 2. Now we have our 9 points. You can add 0 if you want. Times 10 raised to power minus 2. This is our final answer. And the same thing as, you can still write it in this format. 9 times 10 raised to power minus 2. This is our final answer. And remember, this our power 2 is a negative 2 because we counted from the left to the right. Now, number 4. We are given only a 5 whole number. We have our 5 is equals to, converting this 5 to a standard form. We have our 5 times 10 raised to power 0. Why is it 10 raised to power 0? Because one of the laws of indices said that anything raised to power 0 is 1. Therefore, 5 times 10 raised to power 0 is the same thing as 5 times 1, which will definitely give us back our 5. Now we are going to solve some operations with standard form. We'll be starting with addition. The examples. Number 1, they say express the sum of this and this in standard form. And you know that a sum is an answer after addition. Therefore, we're going to express the answer after adding the two numbers to in standard form. Number 1, we have 5 points. We are given 5.04 times 10 raised to power 6 plus, because it is addition, plus 3.14 times 10 raised to power 5. Here, what are we going to do? The first step to take here is to factor out the least power of 10. We are going to factor out the least power of 10. And looking at the two terms, the least power of 10 here is 10 raised to power 5. Now, this will be equals to 5.04 times. If you factor out 10 from 10 raised, if you factor out 10 raised to power 5 from 10 raised to power 6, you will be remain with 10 raised to power 1 plus 3.14, all in brackets, times 10 raised to power 5. Now we're going to multiply out 5.04 times 10 raised to power 1. We have 50.4 plus 3.14, all in bracket, times 10 raised to power 5. Now we're going to add these two. This will give us 53.54 times 10 raised to power 5. Here, 50 plus 3 will give us 53. 4 plus 1 will give us 5. There's no other number here, therefore you bring down your form. Now, reducing this further to a power of 10, this is where our decimal point is. Therefore, we are going to move it front to the least power of 10. Now we count. This is our decimal point. You count 1. Then this will give us 5.054 times 10 raised to power 1, because you move your decimal point from the right side to the left. That's why your 10 here, the power of 10 is not a negative sign. Times 10 raised to power 5. This will give us equals to 5.354 times 10 raised to power 1 plus 5. We are adding the powers because the bases are the same and we have multiplication sign in between. That is one of the laws of indices, the law of multiplication. When the bases are the same and the sign in between there is multiplication, you add the powers. Now, adding the powers of 10 here, this will give us equals to 5.354 times 10 raised to power 6. This is our final answer for question number 1. Once you are given additional operation under standard form, the first thing to do is to factor out the least power of 10. Once you factor out your least power of 10, you can go further and multiply out the remaining. Now we're moving over to question number 2. Number 2, we are given 6.03 times 10 raised to power 7 plus 4.02 times 10 raised to power 5 equals to. Now, remember what I told you, once you are giving something like this, you first of all factor out your power, the least power of 10. And the least power of 10 here is 10 raised to power 5. Now we're going to factor out 10 raised to power 5. Now we have 6.03 times 10 raised to power 2. Because if you factor out 10 raised to power 5 from here, it will be remaining 10 raised to power 2 plus 4.02, or in bracket, times 10 raised to power 5. Now we are going to multiply out. Here, 10 raised to power 2 is equals to 100. Now 6.03 times 100. Let me write it down. 6.03 times 100 plus 4.02 bracket times 10 raised to power 5 will be equals to. Now 6.03 times 100 will give us 603. This will give us 603 plus 4.02 bracket times 10 raised to power 5. Now we are going to add 603 plus 4.02. This will give us bracket 607, because 3 plus 4 will give us 7. Does 0.02 times, you can remove your brackets now, times 10 raised to power 5 is equals to. Now reducing this thing further to power of 10. This is where our decimal point is. Now we're going to place the decimal point. We're going to carry the decimal point and place it immediately before the fourth digit. And the fourth digit here is 6. Now we count 1, 2. Bring it down to here. We have about 6.0702 times 10 raised to power 2. It's not a negative power 2 because we counted from what? From right to the left side, times 10 raised to power 5. This is equals to, we are going to add the powers because we have the same basis and it is what? Multiplication. We have our 6.0702 times 10 raised to power 2 plus 5 is equals to 6.0702 times 10 raised to power 7. This is our final answer for question number 2. Now we'll be moving over to subtraction. The first question is, without using a calculator, find the difference between 8.7 times 10 raised to power 7 and 3.09 times 10 raised to power 6. Number 1, 8.7 times 10 raised to power 7 minus, because it is what? Difference. Difference is an answer after subtraction. Minus 3.09 times 10 raised to power 6 is equals to. Now, remember what I told you in addition. Whenever you are given something like this, what you are going to do is to factor out the least power of 10. Now, we are going to apply the same method here. Now, the least power of 10 here is 10 raised to power 6. We are going to factor out 10 raised to power 6. Now, we have this is equals to 8.7 times 10 raised to power 1. If we factor out 10 raised to power 6 from this, the remaining will be 10 raised to power 1 minus 3.09, all in bracket, times 10 raised to power 6. This is equals to we're going to multiply out 8.7 times 10 raised to power 1. 10 raised to power 1 is sent as 10. Now 8.7 times 10 here will give us 87 minus 3.09, all in bracket, times 10 raised to power 6 is equals to. Now, if you use 87 to subtract 3.09, 87 minus 3.09, this will give us, here, you put your imaginary decimal point here. You carry 1 from this 7, you carry 1 from this 7, it will be remaining 6. You call that one 10. Then you call that one 10. 10 plus this 0 here will give us 10. You carry another 1 from the 10, call it another 10, add it to this 0, you have your what? 10 here. The remaining here will be 9. 10 minus 9 will give us 1. 9 minus 0, 9. Bring down your decimal point. 6 minus 3 will give us 3. 8, there's no number here, bring down your 8. Therefore, this will be giving 83.91. 83.91 times 10 raised to power 6. This will be equals to, if you reduce this 83.91 further, this is where our decimal point is. You carry it, you place it immediately before the first digit. You count 1. This will give us 8.391 times 10 raised to power 1 times 10 raised to power 6. Now, the 10, we have what? The bases here are the same, and we have multiplication in between. Therefore, we are going to add the powers. This will give us 8.391 times 10 raised to power 1 plus 6, which is 8.391 times 10 raised to power 1 plus 6 here will give us 7. This is our final answer for question number 1. Now, moving over to question number 2 under subtraction. Question number 2, we are given 3.4 times 10 raised to power 9 minus, because it's difference, minus 2.2 times 10 raised to power 8 is equals to, remember the method, you first of all factor out the least power of 10, and the least power of 10 here is 10 raised to power 8. Now, this will give us 3.4 times, if you factor out 10 raised to power 8 from 10 raised to power 9, we will have 10 raised to power 1 left, minus 2.2 times, minus 2.2 brackets, or in bracket, times 10 raised to power 8. The next thing to do is to multiply out. 3.4 times 10 raised to power 1 will give us 34. We have our 34 minus 2.2 2 times, or in brackets, times 10 raised to power 8. Now 34 minus 2.2 here will give us, put your 0. You carry 1 from this 4, you will have 3 left. Call the one 10, add it here. We have our 10 minus 2 here will give us 8. Bring down your decimal point. 3 minus 2 here will give us 1. You bring down your 3. Now we'll be left with 31.8 times 10 raised to power 8. Now reducing the 31.8 further, this is where our decimal point is. You bring the decimal point front, you count 1. You have your, this will give us 3.18 times 10 raised to power 1 times 10 raised to power 8. Now we are going to add the powers of 10. This is equals to 3.18 times 10 raised to power 1 plus 8. Will give us 3.18 times 10 raised to power 9. This is our final answer for question number 2 under subtraction. Now we're moving over to multiplication operation with standard form. Now moving over to multiplication, we are given 2 examples here. They say simplify this times this, expressing the answer in standard form. Now writing all the numbers, we have 0.0664 times 0.025. Here, the first step to take here is to change all the decimal numbers to a whole number. Now, we have our changing this to a whole number. We are going to bring our decimal point and place it after all the numbers. Here, we're going to count 1, 2, 3, 4. We're going to place our decimal points here. Now we have our 664 times 10 raised to power minus 4, because we counted from the left to the right. Times, here is our decimal point. We're going to carry the decimal point and place it after all the numbers. We count 1, 2, 3. Here we have our 25 times 10 raised to power minus 3. Now this will give us equals to 664 times 25 times 10 raised to power minus 4 times 10 raised to power minus 3. This is equals to, we're going to multiply out these two terms. 664 times 25 664 times 25 will give us 16,600. 16,600 times, since the bases are the same and it is multiplication, we're going to add the powers of 10. We have our 10 raised to power minus 4 plus bracket minus 3. This will give us 16600 times minus 4 plus minus 3 will give us minus 7. This is 10 raised to power minus 7. Now we're going to reduce this to power of 10. Now here is a 16,600. Here is a whole number. We're going to assume our decimal point is what? Here. Now we count 1, 2, 3, 4. Bringing the decimal point here, you have your 1.66 times 10 raised to power 4, because you counted from the right to the left, times 10 raised to power minus 7 is equals to, we're going to add the powers of 10 here since it's multiplication and the bases are the same. Here it will give us 1.66 times 10 raised to power 4 plus bracket minus 7. This will give us 1.66 times 10 raised to power 4 plus minus 7 will give us minus 3. This is our final answer for question number 2 under multiplication. Now we'll be moving over to question number 1. So we're moving over to question number 2 under multiplication. Now, going further to solve question number 2, what we are going to do here is, so we are going to convert all the decimal numbers here to whole numbers. Now, converting this to a whole number, this is where our decimal point is placed. We are going to carry out the decimal point. Like, we are going to place the decimal point after all the numbers. Here is our decimal point. We count 1, 2. Now, this will give us 125 times 10 raised to power minus 2, because it started from the left to the right, times 10 raised to power 2. Here is our decimal point. We're going to transfer the decimal point to the after the last digit here. You count 1, 2, 3 times 125 times 10 raised to power minus 3 times 10 raised to power 3 times, here, these are where we have our decimal point. Now, what we are going to do is we are going to carry the decimal point after the last digits. We count 1. Here we have our 125 times 10 raised to power minus 1 times 10 raised to power 4 is equals to. Now, going further, we have our 125. Since the bases are the same here, we're going to add the powers. Times 10 raised to power minus 2 plus 2 times 125 times 10 raised to power minus 3 plus 3 times 125 times 10 raised to power minus 1 times 10 125 times 10 raised to power minus 1 plus 4. Now, this will give us 125 times minus 2 plus 2 will give us 0. And 10 raised to power 0 will give us 1. 125 times 1 will still give us 125, which is this 125. This 125 times this 125 here. We have our 125 times 125. Here, minus 3 plus 3 will give us 0. And 10 raised to power 0 will give us 1. Therefore, 125 times 1 will still give us 125. Times 125 here. Times minus 1 plus 4 will give us 10 raised to power plus 3. Because the bigger number here, the sign is a positive sign. Now, what are we going to do? We are going to multiply out all the 125 here. One 25 times 125 times 125. We're going to get 1953125 times 10 raised to power 3. Now we are going to reduce this whole number to the power of 10. Now, reducing, there's no decimal point. We're going to assume that the decimal point is after the last digit. You count 1, 2, 3, 4, 5, 6. Here, this will give us equals to 1.953. We can discard this one. This one is not up to 5, therefore, we discard them. Times 10 raised to power 6, because you can say 1, 2, 3, 4, 5, 6 times 10 raised to power 3. Now, this will give us, here we are going to add the powers of 10 here because the bases are the same and we have multiplication in between. Adding the powers here, we have 1.953 times 6 plus 3 here will give us 9. 10 raised to power 9. This is our final answer for question number 2. Now we'll be moving over to division. Now, moving over to division, the first question, they were asked to evaluate and express your answer in standard form. Number one, we have 4.56 times 3.6 all over 0.12. Just like we did in multiplication, what we are going to do here, the first step to take here is to convert all your decimal numbers to whole numbers. Now, converting them, you need to bring out your decimal point after the last digit. Here we have our 4.56. Here, this is where our decimal point is placed. So what are we going to do? You bring the decimal points, you count 1, 2. This will give us 456 times 10 raised to power minus 2, because we counted 2 times. Here, this is where our decimal point is placed. You still bring it out. Here, it will give us 36 times 10 raised to power minus 1. 10 raised to power minus 1, because we counted once, and we counted from the left to the right, all over. Here, this is where our decimal point is placed. Therefore, we count 1, 2. This will give us 12 times 10 raised to power minus 2. Now we have our, this equals to 456 times 36 all over 12 times 10 raised to power minus 2 times. Now what we are going to do here, is after bringing out all other numbers, the basis of 10, you have your times 10 raised to power minus 2. This is base 10, this is base 10, and its multiplication plus bracket minus 1 bracket minus, for this 10, base 10 in numerator, in the denominator, so not numerator, minus bracket minus 2. It is minus because it is division. Remember, when the basis, one of the laws of indices, when you have division sign, the bases are the same, you subtract their powers. That's what I did here. You're going to subtract the powers here. Now we multiply out 456 times 36 divided by 12. Now we have our 456 times 36 is equals to 16416. 16416 over 12 times 10 raised to power minus 2 plus minus 1 will give us minus 3. Minus 3 minus 2. This minus will be minus times minus will give us plus. Therefore, minus 3 plus 2 will give us minus 1. This will give us equals to 16416 divided by 12 will give us 1368 times 10 raised to power minus 1. Now, reducing this to power 10, we assume that our decimal point is here. You count 1, 2, 3. It will give us 1.368 times 10 raised to power 3 times 10 raised to power minus 1. This will give us, you add the powers, yes, and the bases are the same, and we have multiplication in between. This will give us 1.368 times 10 raised to power 3 plus bracket minus 1 bracket. This will give us 1.368 times 3 plus minus 1 will give us 2. Therefore, we have 10 raised to power 2. This is our final answer for question number 1 under division. We're moving over to question number 2. 0.9687 all over 0.001. Just like we did in number 1, we are going to convert all the decimal numbers here to whole numbers. These are where our decimal point is placed. What are we going to do? We're going to carry it after the last digit. We count 1, 2, 3, 4. Now we have our 9687 times 10 raised to the power minus 4, because we counted from this side to the other side. All over. These are decimal points. We count 1, 2, 3. This 1 times 10 raised to the power minus 3. This will give us equals to 9687 over 1 times 10 raised to the power minus 4 minus bracket minus 3, the power of 10 in the denominator. Now, 9687 divided by 1 will still give us 9687 times minus 4 minus 3. Minus times minus here, because bracket signifies multiplication. Therefore, minus times minus will give us plus. Minus 4 plus 3 will give us minus 1. Therefore, this times 10 raised to the power minus 1. Reducing this to power of 10, we assume that our decimal point is placed here because there is no decimal point. Then we count 1, 2, 3. Here we're going to get 9.687 times 10 raised to the power 3 times 10 raised to the power minus 1. This will give us equals to, we add the powers of 10 here. 9.687 times 10 raised to the power 3 plus bracket minus 1. This will give us 9.687 times 3 plus minus 1 will give us 10 raised to the power 2. And this is our final answer for question number 2 under division.